In 1996, an ambitious applied research project was registered at the Italian Ministry of Industry. That project was the Laminam system. The objective was to produce the biggest and thinnest ceramic slab ever made. That slab would be 3 meters long, 1 meter wide, and just 3 millimeters thick. But the breakthrough of this ceramic product is not only its remarkable size. Its highly innovative characteristics have led to the definition of new classification procedures. Laminam slabs are flexible, block UV rays, and are resistant to chemicals, wear, fire, and freezing. They are also environmentally friendly and recyclable. The ceramic product in itself displays extraordinary properties. However, the height of performance lies in Laminam's composite variants. A fiberglass mesh is joined to the ceramic material using a hardening polymer to give Laminam slabs unique mechanical and physical properties while maintaining weight, flexibility, and workability. Thanks to its innovative forming method, a high level of automation and quality standards, the Laminam process is today considered state-of-the-art in terms of both technology and operational effectiveness. When a type of slab is chosen for processing, the system automatically loads the line with the rototanks containing the required spray-dried materials. The feeding system consists of 1 or 2 hoppers. Mixing is managed by a series of devices which are specially calibrated both for grain size and thickness in order to guarantee uniformity of material in the pressing phase. The pressing system is the strongest feature and the core of the whole production process. This is where the most delicate and most important stage in the production of Laminam slabs takes place. The transformation of spray-dried powders into a single compressed slab without the use of molds and in a single pass. To achieve this, it was necessary to create a special compactor called the compatter, which is the evolution of and an improvement upon the traditional press. The use of the compatter and the consequent expansion of the slab to de-aerate the mix removes the need for the use of traditional molds, which are replaced by a simple molding belt. This molding belt, created specially for this purpose, can be etched to add relief to the surface of the material, creating veins and other surface finishings. As they come out of the compatter, the slabs pass through an automatic trimming system to remove the edges, giving them their definitive size. The entire surface is then cleaned with soft brushes and the slab goes on to the decoration phase. Wet decoration is carried out using rotocolor technology. There is the traditional S5 XXL rotocolor system, or the XXL model with 3 heads specially designed for the Laminam line. The XXL system is completely automated and guarantees consistency of tone, high print definition, and an easy repeatability of the product. After it has been decorated, the slab is ready for the next stage, firing. The firing process has 2 fundamental features. The first is the possibility to use a hybrid roller hearth furnace, which is the central feature of the whole process. The second is the linearity of the process, starting from the drying phase right up to the furnace exit. Drying is done by heat radiation at 200 degrees centigrade. Because of the low quantities of water contained in the material and the reduced thickness of the slab, drying cycles are extremely fast. The hybrid gas-electric furnace is one of the most important features of the whole process. It is a roller hearth furnace in which the firing has 3 phases. The first phase, preheating, is carried out using gas. In this phase, the oven is brought from room temperature to 1100 degrees centigrade. This is usually the phase that requires the highest energy consumption, but the use of gas helps to keep production costs down. The second phase is the firing itself. This is done using electric resistance, which maintains the temperature inside the oven constant at 1220 degrees centigrade, giving the product an elevated consistency of tone. The third and last phase is cooling. A combination of indirect and resistance cooling radiators make it possible to cool the slabs in a highly controlled way, completely eliminating the risk of inner stress. This is an aspect of fundamental importance for slabs of this size. At the furnace exit, a system called Qualitron BS performs quality control. Then the slabs are cleaned with soft brushes and unloaded onto metal platforms. As they come off the production line, the slabs are sent to the composite line. The composite line manages and treats the laminam material. The line is completely automated and applies a fiberglass mesh to the slab. The mesh is joined to the laminam ceramic material by a specially selected hardening polymer. Dosage of the bicomponent bonding agent is controlled by a fully automated system. Temperature, viscosity, mix ratio and recirculation are kept under constant control, guaranteeing an even distribution of bonding agent over the whole surface. The result is a structural composite which combines lightweight, elasticity, strength and resistance to corrosion, chemicals, fire, freezing, breakage and impact. The unique features of the Laminam system have set new production standards. Through the development of more and more technically advanced products, Laminam has opened a new frontier in the world of ceramics, paving the way for new directions and new possibilities in ceramic material applications.